Hello everyone, welcome back to my channel. Today I thought I'd deviate a little bit from the math and nature videos normally featured on this channel and talk about a new interest of mine, which is programming, more specifically writing code in Python. If you don't know, Python is a high-level coding language, which means it's pretty easy to learn for anyone. I enjoy writing several programs in it, so today I thought I'd show you what I've written. So hopefully you learn a thing or two. Right, so here I am at my IDE. Basically the environment where I write all my programs. So I use Visual Studio Code, which is, I just prefer using it because of the amount of plugins and languages you can use, and they're all for free, so I just like using this one. But you can pretty much write code anywhere you want. You can write it in the command prompt online in an online notebook, or pretty much anywhere else. So Python has plenty of opportunities for places to write your code in. Basically what you see on your screen right now is the first program I ever wrote in Python. It's sort of a calculator for this game called Growtopia that I used to play. In the game, to kind of increase the amount of items you have, you can sort of farm them, basically just increasing the amount. And I created this program to be able to calculate the amount of items you can gain from the farming process using this formula I came up with here. Basically, the program uses a dictionary of items, so there are key and value pairs corresponding to sort of how farmable the item is, and then I take input from the user, so basically whoever uses it can just activate the program, see this list of items that they can calculate. For example, let's say I want to calculate rice. Then it asks me how many seeds, basically items in the game that I'm starting with. I can write any number here, for example 1000, and it asks me how many times I'm planning to farm, let's just say 3, and then it returns that by the time I finish farming I should have 1469 seeds, so it calculates that based on the formula I've written here. So I think this program really taught me how to write sort of mathematical equations in Python, which is really important because Python often deals with data and handling that data, especially large groups of data. So being able to come up with formulae based on information that you get from the user is very important. But if you're more experienced in Python, you can probably tell that this code is kind of clunky and it doesn't look that good. I could definitely be more concise. I'm going to talk about that later, though. I wrote this code independently without any help from anyone or any sort of tutorials. I played a lot of this game, so I thought it would be kind of practical or interesting to code a calculator for it. But the rest of these programs, as you can see, there's this folder called Jupyter, which has quite many programs in it. These are in relation to a course I'm attending on Udemy on Python, which has a lot of kind of tasks for students to practice at home, and I've written a lot of code for that course. So next we're going to go over all those programs. So now I'm in the Jupyter folder, which has all of my programs that I've written for the course. There's some code that's missing here because I forgot to save it, but there is quite a lot of practice here. Each file is going to be more sort of advanced than the last. So the first file here is a Jupyter notebook, which is an online environment to code. So it's much harder to save your code, but it is easier in the sense that you don't need to create a new file and constantly be saving those files because everything's happening online. So here I'm just practicing writing functions in Python, which are extremely important. So you can see the syntax here. So syntax basically means the way you have to write something for the computer to understand it. So the syntax of functions in Python is def for define, then the name of the function, and then if you need them, you can add some arguments in this definition of the function to know what the user has to pass in to run the function. So for here, I'm calculating the volume of a sphere based on a radius that the user puts in So, and you can also see that I've imported a module named math, which allows me to use different kinds of things such as pi to get a more accurate calculation. So if a user passes in, for example, 2, then based on the radius, you cube the radius, which is what this means. Then to get the area, you multiply this variable by pi. And finally, to get the volume, you multiply the variable area by 4/3. And then you, in the function, to get back your information, you just say return, followed by the variable. So this returns 33.5, and so on and so on. So it looks like it works. Let's try, for example, 3. Right, so if you were to Google the volume of a sphere and pass in a number for the radius, it would give out the same result. The rest of these functions are, I'd say, as simple, if not simpler. This one just checks if the given number by the user is in between two other numbers. So if you give the number, just run this. If I gave the number 2 and I checked if it was between 4 and 5, it would tell me it's false. But if I gave, for example, 4.5, then it would say it's true. Here, this one looks a little bit intimidating, but it's simply given a sentence or any word, basically, which in Python is called a string. It counts the amount of capital letters and lowercase letters by adding them to a list. A list is declared with square brackets, like this. And then it finally counts the length of that list to tell you the amount of capital and lowercase letters. So here I have the sentence, my name Jeff, which gives me 3 capital letters and 7 lowercase letters, but I can put anything here. For example, my name is Gustav. Let's make this V large. So it would have 1 capital letter and 13 lowercase letters. This function checks if there is an item already in a list, and if there's not, it adds it to that list, and then it checks the length, or it prints back the list. So anything you print there is going to be unique. So you can see if the user passes in a bunch of 1s, a bunch of 2s, a bunch of 5s, then they would only get back 1, 2, 3, 4, 5. So pretty simple. Here, what I'm doing is just adding all of the numbers in a given list and then returning it. Here, I'm checking if a word is a palindrome. Palindrome basically is a word that is the same spelled forward and backward. What this means, this line here, is it returns whether or not. So it would return a true or a false if the word that the user puts into the function as an argument is the same of the word backwards. So this basically means from the beginning of the word to the end of the word backwards. So it prints out the entire word backwards. And as you can see, if I put the word in water, it would say false. Technically, this might create an error because one of the letters is capitalized. But it's false. But if I were to put in race car, it would say true. Here's a pangram checker. A pangram is basically a sentence that contains every letter of the alphabet. So here I've just copy-pasted some random pangram and checked if... Oh, whoops. Moving on to the next program. Here's some practice on classes. I was having a lot of trouble understanding what classes were. I think I've got it now. So basically, classes are... in Python, there's a bunch of built-in object types like strings. Like this is a string. Numbers, lists, dictionaries, which I talked about before, and so on and so forth. But you can also create your own objects with classes. Basically, what they allow you to do is create any object with a bunch of attributes of your liking. So, for example, here I've made a multiple choice quiz, and I've made a class for questions. So questions, their attributes are question and answer. So every question is a question, and every question has an answer. So that's kind of a must if you're creating a questions class. So what I've done here is I've created a list of questions. So what is 5 plus 10? When did Estonia become independent? What is 7 plus 7? 7 times 7. And I've made some answers that are just questions objects with the question here. This is the question here. And the answer is the answer argument. And then I've kind of made some game logic for the test. So let's run it. So first, I was trying to mess around with if I could actually, kind of create questions in the program. But for now, let's just try to answer the questions. So it just first asked me, what's 5 plus 10? I say 15, 19, 18, 7 times 7 is 49. And it says my score is 3 out of 3. So it also has a built-in scoring system. So if I were to start the program again and just answer randomly, then I would get 0 out of 3. So this is quite simple. It's so it just checks if the answer is indeed the answer that was given in this answers kind of list. And if it is, then it just adds 1 to my score. So this is pretty simple. It was kind of annoying to try to code out, but based on what I'm about to show you next, I think this is still pretty simple. Here's some more class practice. Here I've basically made 2 classes for coordinates and cylinders. And here you can see there are many attributes. So this init attribute basically just means initialized. It's an initialized function. Like you can see that it has the function syntax. And you need this if you want to create an object for the class. So basically this initialized function allows you to give attributes to the object. So here, since I'm calculating the distance and the slope between 2 coordinates, then the attributes are gonna be the first coordinate and the second coordinate. And each coordinate is gonna be a tuple with an x and a y axis. And based on that, it's just gonna calculate the distance and the slope. The second class is a cylinder class, where based on the attributes radius and height, I can calculate the volume. I just have a variable where I create a cylinder object with a radius of 5 and a height of 10, and it prints out the volume of the given cylinder is the volume. So let's just run this. So first it calculates based on this coordinate class, since I've did the same thing here, and then it gives me the volume of the given cylinder, which is this one. Next, here's some homework on errors, more specifically error handling. So these try and except keywords. What they allow you to do is if you know or you have a suspicion that a user can kind of accidentally break your code, instead of crashing the code like it normally would, you can just print something or break out of a loop or just skip that part of the code. So for example, that's if you're using an app, you wouldn't want the app to just close whenever you did something that wasn't intended. You would just want it to say, whoops, you can't do that, right? So try and accept keywords. So exception handling allows you to do that. So here's some simple functions that just have, so I'll just explain the first one. So here it's a function where you iterate through a list of objects and then you try to square all of them and return it. So here you would square 2, square 3, but here you see that there's a string or a letter and you can't really square that. So you would run into a type error, in which case instead of crashing the program, it would just print, you fool, you can't square a string, and then break out of the loop. And that would kind of finish the function. And it would just break out of the loop instead of crashing your program. So here are some more functions. So problem 2, this is a 0 division error. Well, I mean, at least you're expecting a 0 division error. And here's a try except else finally. So these are the same thing, else basically if there's no error, so this try keyword, like this goes through, then it would just print no error here, then go through with the rest of the program. And finally prints no matter what, so if there's an error or even if there's not an error, it would still print. Moving on to the next program, this is some more class practice. Here I've created a bank class with an owner and a balance, and you can deposit. This is a deposit method is what we call it, and you can withdraw some money with these method functions inside the class. So here I've just created an example. So let's say there's a bank object with an owner John Cena, and he has $1 million in the bank. So if he were to deposit $500, he would then have $1,500,000. If we were to withdraw, then he would have 999,500, so it works. Here we have some generator practice. This is a little bit more advanced, but basically generators allow you to, if you're dealing with some code that would create a long list of objects or return a huge list of objects, that would use a lot of memory or space on your computer. And if you want to save space, you could instead use a yield keyword, which would basically just go through all of the necessary objects but not kind of save them on memory. So you could just kind of print them in place if you wanted to, and you wouldn't use up that much memory on your computer at all. So this is more useful for if you're dealing with programs that are several megabytes or gigabytes large. So for programs that are this small, it doesn't really make a difference, but the bigger the program, the more useful any memory saving tools are. Finally, this is a program that's kind of a work in progress right now. As part of this kind of task given in the course, I was supposed to unzip this file, which I managed to do. And then there are some instructions in here to try to find like a kind of a phone number. It still hasn't really... I'm still not finished with this. I think the error is with my PC. I might have the wrong directory written in this file or something, but so hopefully I can resolve the issue. So this is my first sort of big game that I coded. It's tic-tac-toe. Basically it works as any other tic-tac-toe game would work, with the exception that each row is actually a list of empty strings, and whenever you sort of put a cross or a circle on one of those squares, it actually assigns one of these strings to a letter, so either X or O. And then if you get a full line or a diagonal line of your chosen symbol, then you win the game. So the other special thing in this game is that you're not actually playing against another person. You're playing against a kind of a robot who's actually randomly choosing the squares to place their symbol on. So there's little risk of you losing the game. Let's just give it a shot. So it asked me would I like to be X or O, or a cross or a circle. So I want to be a cross. I pick the first row and I want to place my cross in the first square. So it prints the board out for me, then the robot makes their move. I pick the second row, place it in the second square. So I'll just pick my third row and the final square to win with the diagonal. Then the opponent can't do anything and the game asks me if I want to play again. So right now I don't. And then it says goodbye and then it exits the file. So this is pretty simple, but since it wasn't the first game I ever coded, it took me a long while, so I am pretty proud of this though. Finally, the last program I've written for now is a sort of simulation of the card game War, which if you don't know is basically one of the simplest card games where two players simply compare the sort of strength of each other's cards, and whoever has the so-called stronger card gets it for themselves, and the winner is the person who has the most cards at the end. So as you can see, this folder is pretty big. So this is the sort of game logic file, but for this game I've created a card file with a card class or a card object, which basically defines every card in a deck. Then there's a deck object which has all the cards in a deck. So then there's a deck class which basically has all the cards in a deck, so 52 cards, and it allows you to also shuffle and deal cards from a deck. And finally there's the player object, which is basically I'm simulating two players playing the game. So I want to have players who have a hand of cards, players who are able to add cards to their hand, and also deal cards. So altogether, when I import those classes into this game logic file, I'm able to create two player objects. So basically sort of robots who play against each other. And then there's a long string of commands for the sort of robots to play. And basically when we run this code, what we see is what player won the war comparison. And if the cards are sort of equal in power, then a war begins, which is basically a competition of who can manage to find the bigger card, and they get all the cards for themselves. So after that, there's a few more comparisons, And when a war begins and one player doesn't have enough cards, which I believe here the threshold is 1, if one player has only 1 card or 0, then the game can continue and the other player with more cards automatically wins. So then it tallies up the amount of rounds the game lasted for and how many wars were held in total. So as you can see, each time we run this code, the amount of wars and comparisons that take place vary a little bit because it is obviously pretty random which player wins which comparison, but the amount of wars doesn't vary too much because of these pretty strict rules coded into the program. Thank you guys for watching. Hopefully you understood my code, hopefully you learned a thing or two, and if I got you interested in Python, that's a big success. So have a nice day.